Hello, viewers. Last episode, I showed you what I had to do to make sure I would not get electrocuted while taking a shower. Many questions came to my mind, so I decided to get a brand new maxi douche and perform some measurements in a quote-controlled unquote environment. And here we have it. It comes with a user manual. It is all in Portuguese, but you can find a somewhat abridged version in English and Spanish on their website. The voltage and power rating for this model are 220 volts, 5.5 kilowatts. On the back side we have more technical information. It rates the circuit breaker for 30 amps. It says that the water resistivity should not be inferior to 1.3 kilo ohms by centimeter. Here it shows that on the lower temperature setting it consumes only 3000 watts. It also says here, important notice for your safety, to avoid electrical shock hazards, connect the ground wire of this device to a grounding system that complies with the Brazilian code NBR 5410. This is the installation manual. It says here that this product has been approved by the National Institute of Metrology in Metro and that it complies with the Brazilian standard NBR 12483. Another important notice is that the manufacturer recommends that children, old or sick people, physically or mentally disabled people should be supervised while using this product. Other recommendations are that the wires must come out of the wall at 13 centimeters above the water pipe and that no kind of power plug should be used. And finally, do not use the neutral wire as ground. So we have torn down the shower head and here we have the ground wire. It is made of copper, coated with something that is probably tin. This ground wire goes through here and also supposedly grounds the incoming water and then it goes out through this bundling hose and ends on the other side with a sign that says, avoid the risks of electric shocks. Connect the grounding wire properly. I think you got the idea. Here you have a warning that you must turn off the circuit breakers that is recommended to be exclusively installed for the product at the distribution panel of your house before you let the water run through it for the first time. The heating element should work totally immersed in water. The failure of doing so will cause the heating element to burn out. There you find the diaphragm that pushes the power switch on top of the shower head. I removed this protective cap from the top. When you leave the temperature switch on the cold position and opens the tap, the water pressure pushes this power switch upwards. Here are the wires from the power line, but contact is prevented as you can see, although the other side is free to touch the terminal. The segments of the heating element are connected like that. The longer segment is connected from there to here and the shorter one from here to here. This segment is short-circuited when you leave the temperature switch on the high temperature position. With this only the longer segment will be energized. On the low temperature position, the short circuit is removed and the two segments work in series. With this the resistance is higher and the power is lower. Good old Ohm's law. We will run our tests with our temperature switch on the lower temperature position because our circuit breakers are only capable of 20 amps and I am not interested in testing the shower for power but for grounding safety. Well, here at BSFEEChannel we have a convenient setup for testing our shower head. We have a two-phase 220 volts connection and a ground connection. This blue wire here is the neutral and it is not going to be used. We will leave the ground wire disconnected for the voltage measurements. So, I will let the water flow with the temperature switch on the low temperature position and I will measure the voltage between the ground wire that is immersed in the water and the mains ground. Water is flowing, it is getting heated and we can see that we have more than 64 volts, quite considerable. We can see that the water is energized. I am going to measure again with the temperature switch on the cold position because we noticed that only one of the contacts of the switch is blocked but not the other, which could convey electrical potential to the heating element and consequently to the water. And there you have it. It is even higher at around 124 volts. Now we are going to measure the leakage current that flows between the shower ground wire and the mains ground when it is connected. We can see that we have about 9 milliamperes. quite high. Now I will close the tap, turn the temperature switch to off position, and measure again. Ironically, when the shower is supposedly turned off, the leakage current is even higher, around 15 milliamperes. No wonder, because we saw that the voltage between the ground wire and the mains ground is higher when the shower is turned off. This is the effect of not isolating both contacts to the heating element. You can see that this tap is made of metal and that is in contact with the water that goes into the shower head. I will disconnect the ground again and I will measure the voltage between the tap and the mains ground. Do not know if the camera can capture it, but we have here around 35 volts. And now, let us measure the leakage current between the tap and the mains ground. We have around 400 microamps. Now I will place this copper-clad board closer and closer to the shower head like this and measure the voltage between the water and the mains ground. So here we go. Around 10 centimeters from the shower we have almost nothing, 3 centimeters, 4 volts, 2 centimeters, 10 volts. Now with the board touching the shower head we have around 50 volts. And as we move the board away the voltage disappears. Now we have the ground wire connected to the mains ground and we are going to see how this makes things any better. Now let us measure the voltage at the tap and we see that it is lower than before, but it is not zero. Around manageable 8+ volts. And likewise the voltage on the water stream is lowered considerably, and when the copper-clad board touches the shower head the voltage is also lower, although it jumps around a little. The International Electrotechnical Commission, IEC, of which Brazil is a full member, states in their General Principles of Safety that where possible, designers should specify design criteria that will eliminate, reduce or guard against hazards. Where this is not practicable because the functioning of the equipment would be impaired, specify the use of protective means independent of the equipment, such as personal protective equipment. Where neither of the above measures is practicable, or in addition to those measures, specify the provision of markings and instructions regarding the residual risks. Although we tend to think of the ground wire as a protection just in case, when the specified insulation fails and for some reason the user may be exposed to mains voltages, the IEC specifies what they call protective conductor current, which is the current flowing through the protective earthing conductor, that is the ground wire, under normal operating conditions. This means that they admit that some devices need the ground wire connected at all times to offer adequate protection. That is the case of our shower head. We also tend to think, at least I do, that any modern electric or electronic product should not make a human body conduct any current at all. 0 amps. Again, the IEC experts define what they call the touch current, which is electric current through a human body when it touches one or more accessible parts. In some cases a 3.5 mA current or more is admissible by their standards. I have got the impression that the Maxi Ducha seems to comply with all those standards. No device can guarantee safety by itself, and safe practices should go along, like proper installation, maintenance and operation. These electric shower heads are efficient. They have been certified to achieve a 95% efficiency according to the Metrology Institute. In today's quest for a low-carbon footprint, such an efficiency is indispensable. It is a very affordable solution for places where water does not have to be heated much above ambient temperature. On the other hand, when it comes to electrical safety, it seems to me that the reliance on the ground wire connection and the water resistance is a little precarious. We showed that a current up to 15 milliamperes can flow through the ground wire when it is connected to the mains ground. If the ground wire fails, it could flow by whatever alternative means available. The human skin is not a short circuit, but this figure represents the order of magnitude of the risks involved. According to this graph, 15 milliamps flowing from your left hand to your feet is not enough to cause death by fibrillation, but it is perceptible and can cause muscle contraction if you get exposed for more than 1 second. It is a harsh discomfort you should not be experiencing at a time so relaxing as a good hot shower must be. Can you be killed by one of those? No doubt. Like any other appliance connected to the mains, the risk of electrocution is not zero. Does it deserve the name suicide shower? I am not sure. If you have a sludgecore punk rock band, however, the name would be perfect, I guess. Why do people freak out at the sight of a suicide shower, even if properly installed? Perhaps the Joker can give us a hint. Nobody panics when things go according to plan, even if the plan is horrifying. When hundreds of thousands of people get killed every year in car accidents, no one panics, because it is all part of the plan. But when there is a prospect of someone getting killed by a single electric shower, well then everyone loses their minds. And in case you are wondering, no, I do not use an electric shower head at home. Thanks for watching. Have a good night and stay beautiful.